1, 2, 3, 4. 4, 3, 2, 1.
I hope everybody had a Merry Christmas. We had a pretty good year. Got to see all our loved ones and had fun. Got a lot of awesome gifts, some of which I'm going to start using on my videos. My mother-in-law was kind enough to gift me a chest mount for my GoPro. So this will make doing the in-depth videos a lot easier. And then my uncle found me a Bluetooth microphone. So I don't currently have it hooked up, but I'll get it hooked up here in a minute, and hopefully it'll make the sound quality a little better. But today we're gonna get working on a project. Either I'm going to finish the puddle light on the blue car here, or I will install my in-coolant temperature probe for my electric fan. So stay tuned and let's see what we can get into. All right, well, here's the breakdown of what we got going with the projects today. So one of them is finishing up a repair for something that happened to one of my additions. My wife had bought me a set of puddle lights for, I think it was for Christmas several years ago, and I finally got around to installing them when I was doing the body work, because you have to drill a hole in the bottom of the door and make some modifications. But got them put in before I did the body work, and I think this side's still functioning, so you can probably see it if I pop the door open. It's probably too dark. Yeah, you can't see it. So I had that put in there, and one day, just a month or two ago, we were going to go take the blue car out, and I had it out here in the garage warming up, and I went inside and left the door open. And I came back out and I jumped in the driver's seat, and there was smoke just coming straight out of the door here, and it was coming out from inside the door panel. And so I shut the car down and disconnected the battery real quick. Well, I came to find out that the light, the way it was made, the wiring for it came out the top of this guy. And so there was a cap that was on the top, and then in the middle of the cap was just a hole that the wiring came out of. Well, I took the bumper for the window regulator out, and it was just resting on top of the light here. Well, it ended up squishing the wiring up against that metal for the cap, and it shorted out and almost started a fire. Luckily, I caught it before anything went up in flames, and disconnected everything. And then I ended up along the way losing the cap for the top of it, so I ended up having to rig up my own little cap. Alright, so with the light, really all I need to do is solder my little LED chip onto, or solder my wires onto my little LED chip. I was having some trouble, they're gotta go just like that, but I was having some trouble. I tried soldering them on already with the existing solder that's on there, but there's just not enough of it, and I of course couldn't find my rosin solder anywhere. And so today we stopped by Ace and picked up a new little package of rosin solder. I did notice that they do carry two different kinds. There's 60 or 40-60 and 60-40. I got the 60-40 because in my mind for this, having something that has the lower melting point will make it a little easier to use without damaging that chip here more than I already have, because the only soldering guns I could find are these bigger Weller soldering guns, and they're not too great for doing precision work on boards. So you can see I already heated it up pretty good, but hopefully with a little more solder I can goop it on there and get them soldered on, test it, and move on. So it's sounding like this is going to be the project for today, or at least one of them. So enjoy. Hate soldering.
Yeah, you suck. Just all around you suck. Suck, suck, suckity, suck. I don't know what to do. Too frustrated. Suck!
Okay, I finally got sick of yelling and cussing and grabbed a little clamp and clamped the chip down. Now we're gonna try and solder it for the millionth time. Picking up all my stuff here from the failed attempt at repairing the puddle lights, and we're going to move on to the electric fan. So this is the in-tank sensor, in-coolant sensor. It's just an on and off switch, and it has a range of 200 degrees to turn on and 185 degrees to turn off. So I've always, ever since I got this car running, I've ran this Black Magic electric fan, which everybody always likes to talk crap about, but mine's always worked really good for me. I've never had any issues with it. But when I first got it going, and then at some point the controller went out, and so I just bought a universal one from AutoZone and wired it in this existing housing here and just hacked it up and called it good. It has a little adjustment knob here, and I ordered a 3-core aluminum radiator, and I actually really like these radiators. Both Alicia and I run them, but they're from a company called Shepherd Auto Parts on Amazon, and it's all aluminum and hand welded, polished tanks. It's nice, but I've never liked the push-in probes for these controllers, and I just don't like messing up my pretty radiator. And also, you know, I mean, you can get a leak from it if you screw it up. But I've never liked this also because when I'm sitting in traffic, like the other day when me and Michaela were out doing last minute Christmas stuff, we were just putting, trying to get out of a parking lot or this shopping area, and the temperature kept rising up. It would get up to about 220 or 230, and I just don't like that. And once you get moving, then it kicks the fans on because air actually flows through here, and then that allows the temperature sensor that's back here to get a more accurate reading, because the air is heated up from the radiator, from passing through the radiator. Well, that kind of sucks for just sitting and idling, and the last straw for me the other day was going out with Michaela and getting nervous about the temperature. So I decided that it was time to fix that issue, and I had originally sent a bunch of different things to my mother-in-law for her to pick something out for me for Christmas, and she ended up getting me everything instead, which I greatly appreciate, but certainly wasn't needed. And so it was, she had gotten me this kit. So the first thing I have to figure out is what I'm going to do with the temperature sensor itself and where I'm going to put it. So on the small block Fords, there's a few places. It's usually always in the intake. There's a stock fitting here from the factory, and I don't know if you can see it, but this I believe is the ECT sensor for the computer that tells the computer at what temperature the engine's at for timing and various other adjustments. And then there's a barbed end at the top, and this from the factory goes to the heater core to supply heat. I just have it looped around. And then the water necks on the small block Fords, usually there's always a boss on the top here, but it's not drilled out. I went ahead and drilled mine out when I was getting it built so that I could run my aftermarket temperature gauge in the car. And so that one's taken up with my temperature gauge. And then the last option I have is right down there. So this guy right here, I believe, is the stock gauge. It's just a little single wire push-on connector, and so I'm pretty sure that's the stock gauge. If it is, I'm considering just ditching it because I don't think it works anyway. Or if it does, it's not accurate. But that'll probably be what I'll do, is I'll just take that out of there and put my new switch, temperature switch, in right there. The other thing I have to figure out is the actual electronics part of it, because what we have in here is just a rigged up universal controller from AutoZone, and then I ran the probe out this part and then around, and so we'll be ditching that, and then we won't need a dial anymore because the range is set in the temperature sensor itself. And I think usually they have a marking on them somewhere. Yeah, that one right there. It says 200-185. So what that means is that it will close the switch at 200 degrees. And so when the temperature reaches 200 down here where the coolant is, then it will close the switch, which will turn on the fan. And it's supposed to keep that switch closed until the second number, which is 185. And so once the fan or fans gets it cooled down to 185 degrees, then it shuts off. And so we'll just have to tear this apart and then see if there's any way I can reuse the existing relay or anything like that, then I will, but we'll tear into it and see what happens. So the first thing we're going to do is take off these two screws right here, one there, and get this cover off here. Alright, we got our little panel off there, and it's kind of in the way. I'm going to go ahead and pull out our line here for our probe. We have it, it's kind of just tucked in here, and I'll pull that out of there, get that out of the way, and then we will pull our adjustment, or it's really a potentiometer, but it's just the temperature adjuster, and see how it's hooked up. Alright, so we got the little temperature probe line out of the way and pulled our thermostatic controller out, and after looking it over, and then I also looked up the wiring diagram for this particular fan. It's really two completely different systems here. This one is completely driven off of power and where it's getting power from. It runs power to the switch, or to this thermostatic adjuster thingy mabobber. It runs power to this, and then once this reaches a certain temperature, because this is conductive, I suppose, it will send the power out to the other side, and then it runs the fans. You can also wire in a manual switch, but that manual switch has to receive power, and so on that terminal from the manual switch, it needs to receive 12 volts, and there isn't any power running through this particular switch. And so what it's doing is it's meant to be ran with a relay, which is the same relay that's in here, but it's a lot more simple. And so what they're doing is what's activating the relay to send power to the fan is this grounding, and so when this terminal grounds out, it activates the relay. Well, after looking everything over, I'm really debating just pulling out my stock gauge sensor here, screwing in my new switch here and there, and then running, I'll take my ground. This is actually the ground for the fan right here. And I'll take this connector off the end. I'll put a female spade in it, and I'll just put it in the top of my switch here. And so what it'll do is the fan will actually be getting power all the time, but it won't actually run it until the ground is grounded. And when the switch opens up, then it's essentially opening a full circuit for ground. So that actually works out really good, and I think I will try that. Just pull this off here, connect it on top of here, and take this one out, and really simple. That way I can at least try it and test it. And I'll probably just button the rest of this up and put it in there. I mean, at the very least, what it'll be is a way to shut it off. If, say, I'm working in here or something and I want to shut it off, I can just flip that dial and it'll shut it off. And then whenever I'm running, then I'll just have it all the way fully on, and the system will only be activated by the range on this. So we'll do that. Okay, we got all the electronics from inside the fan controller out, and while I was pulling everything out, I broke the spade terminal on the main board here, and so there's one that's supposed to go right here into these two posts, and the terminal itself is right here. You can see it snapped right there. This actually happened previously, or it happened once already, and I repaired it once and it's been fine, and then I went to pull that connector out and of course it just popped right out. So I'm gonna try real quick to see if I can get it soldered back together. If it doesn't work first try, then I'm trashing all of this and just putting my relay and everything to run my new temperature switch. Okay, well, it did not take me long to ditch this thing. As a matter of fact, it was a matter of already losing my brand new solder that made me decide to just rip it all out and change it up. It's actually wasn't too bad. I have all the connections I need here, and they already had some female spade terminals on them. So what I did was I just took the relay from the kit and plugged in the spade terminals into their corresponding locations with careful research and due diligence. So it should just run as the system's supposed to, as directed by their impeccable instructions here. I mean, top notch, top notch. So, you know, it's pretty much like rocket science here. This is it's like geometry, mathematics, all of the smart stuff. So I'm pretty sure we're just going to touch this on and everything's going to be good, but we are going to try it and let you see. Well, that doesn't seem bad. Okay. Well, nothing bad is happening so far. So, rather lackluster start is hopefully a good sign. So, I have all of my connections into my relay from the kit there. I have my new sensor that's screwed into the lower intake right there, and it has a nice new gold-plated female connector on it, and that's running back in here. So yeah, I'm gonna give it a quick run through my brain, make sure I didn't miss anything, check a couple more things, maybe see if I can come up with a way to test to make sure it's functioning correctly before I let it warm up and idle. But let's keep messing with it and see if it works. All right, I have an idea of how I should be able to test this to see if it's functioning before I start the car up. And once again, we are using the handy dandy test wires. Ooh, in blue. So the way I think this should work is that the whole system is activated and the relay is switched on when this wire is grounded out. So if I take my ground and my test wire here that's hooked up to the ground side of my battery, and the other end of that wire goes to the block. So if I have that there and I ground the spade terminal that I have there on the on that sensor, where is it? There it is. It's hard to get in here. I got a freaking selfie stick on here. If I touch that, then it should kick on. So let's try it. It's trying. I hear it clicking the relay over, but I don't hear any fans running. No, no fans. So I got to look at the output side here of the I got to look at the output side of the relay and make sure I have the correct wires hooked up there. So we're gonna double check that, move a couple things around, and see if we can get it working. So I think that I figured out why the fan wasn't turning on. So when I originally had put all the wires together in there was two wires that I pulled off of the chip here that went out to the motor, the fan motor, and I just hooked them both up to the relay. And for some reason I was sitting there thinking, well, maybe it's like a high and a low speed or whatever, and I was like, well, let's just hook them both up and try. Well, I believe that I know that one has to be power and one has to be ground to complete the circuit for the motor. So what I've done is I've taken my wiring that I made for my puddle lights that I'm not able to use, and I just made a ground for it just to test it. So it goes over here to a chassis ground and then plugs into the, what I'm assuming is the negative side of the motor for the electric fan. Now, I will say one thing in this situation, I'm going to be cautious because I'm pretty sure if you reverse the polarity, so if you switch these two wires, then it would change the direction that the motor would spin. And so you would, if you have it set up to be a polar like what I have here and it's pushing, then it's counterproductive and isn't going to be cooling efficiently, and it probably won't last long. So always one thing to keep an eye out for. But let's give her another try, because I think that was the issue. We could hear the relay clicking over, but the fan wasn't turning on. So I'm just gonna take it and touch it on here. Maybe if I can get to it. Well, let's make sure our connections are good here. Yeah, all that looks good. Okay. Let's make sure that we are making good contact on here. Yeah. There it goes. So that'll do it. Well, it's a good way to test. I'm sure my neighbors thank me because it's 10 o'clock at night now and don't have to warm up the Mustang to test to make sure that it's working. So it looks like the system is wired up correctly and it should function as designed, as long as this sensor here is working right. We did try to test it. It was kind of finicky. I couldn't get the water temperature over 200 degrees, so we're just gonna have to give her a try and find out. So stay tuned. Tomorrow, hopefully sometime, maybe in the morning, we'll start it up and give it a try. Good morning. It is a new day and we are going to come out here and test the electric fan upgrades we did yesterday. It was a beautiful day in Colorado. Don't mind all my junk, but it is just gorgeous. Feeling good. So yesterday I started out trying to repair my puddle light, which did not end up working out, and then I decided to jump on the cooling for the Mustang. And so I pulled out the old board, the controller and the relay, basically all the internals for my electric fan, and I replaced it with a relay from this kit that it just supplies a temperature probe or a dang temperature switch with a range. And so I just took out my factory coolant temperature for the gauge, took out that sender and replaced it with this one, moved a couple wires around. I ended up at the end of the night adding a ground so that all the wiring is done. All the wiring just runs through here, which I'll eventually clean up, but got it all put in there, and then added a little pizzazz to it. It's the new Overland edition, so I don't know, I might cover it up with this vinyl decal right here. Put the Ford emblem on there. I haven't decided, but it just covers up those holes from the knob for that controller. So now let's fire her up and see how it works. Sit here and idle until the temperature starts going up. We'll keep an eye on just sit here and loaf. Enjoy. Okay, we're starting to get a little bit of heat in her, so it looks like it just went above 140 degrees. She's idling okay. I had the battery disconnected and it's kind of been chasing idle a little bit, but still sounds pretty good. We'll let that temperature get up. Once it starts getting up closer to 200, we'll grab the infrared thermometer and check it. While we're in here, I wanted to show you guys my rally mirror I put in and its final location. So I was able to get it tucked up and back as far as I could. And so it's tucked up as close to the top edge of the window as I could get it. You actually can't even see it from the outside because of the tint eyebrow. But it looks pretty good. It's taken some getting used to for sure, but once you're used to it, it's really nice. I mean, you can see everywhere, all around. So, pretty sweet setup. I like it. I know it's probably not for everybody, but I always wanted a rally mirror ever since I was a kid. So, I got me one. I don't know if it's just this cool Colorado weather or what, but she ain't wanting to heat up. It's been about another 10 minutes and it's still just barely over 140, so might have to take her out and romp her around a little bit to get her heated up. Okay, we're just about at 180. I can't remember what thermostat I put in this car. I assume it's either a 160 or a 180. I ordered a higher temperature range for the sensor for the fans just to be safe so that I'm not fighting against the thermostat. But we are just about at 190 and we'll go around the front, grab the infrared thermometer and see when and if it kicks on. Alright, looks like we've still got a ways to go. We're showing 145 or so. Might take a little while longer. While we're in here and it's running, I want to check and make sure there's no leaks on the sensor. It looks nice and dry, so that looks good. Okay, we are showing 190 degrees on the aftermarket gauge, so it's creeping up there now. When I measure it up on the coolant on the water neck, we're showing about 40 degrees lower, but that could be the difference of just the coolant versus the outside temperature of that metal, you know. Yep, it looks like the thermostat's all the way open. The upper radiator hose got real soft. You can feel it flowing through there, so that should be open. I'm just squeezing it and pushing it down to try and get any air bubbles out of there that I might have got in the system when I pull out that 200 degrees on the aftermarket gauge. So right about where that dotted line is usually where the fans would flip on with my old setup, but you had to be driving, so it had to have that airflow through the radiator for it to actually kick it on. I'm hoping they'll flip on pretty soon. Much higher than this I don't really like, so if that sensor doesn't flip them on pretty quick, then I might get the next range lower, swap it out. It just kicked on, and it was probably around 210, 215 on our gauge. So I thought I heard something out there, but flipped the fan on, looks like it's starting to go down now. So kicked on at 210, 215, and we'll let it go down here. See where it shuts off at. Doesn't sound like it's running very fast. And we're right back down to the 200, 205 area. I never really liked this gauge. It just doesn't, it's not very granular. You can't tell with a whole lot of accuracy what the exact temperature is. Sorry, it just shut off. So it flipped on around 205, 210, shut off at 195, almost 200. We'll let it run some more, let it cycle through and see how it does. So far, I mean, it's a lot better than what it was. It wouldn't have flipped on at all if I still had that temperature probe set up on there. So should be good to go. Overall I'm happy with it. I'd like it if it was a little cooler, if it flipped on a little earlier, but it's not bad at all. Overall it's a win. Switches on and off as it should. Seems to go a little bit higher than I thought it would. It's like it's going up to about 215 or so before it closes the switch and kicks the fan on, and then it shuts off around 190 or so. But you know, it's better than nothing. I don't think I got to worry about it overheating, but I just prefer it to run a little bit cooler than that. One thing I did notice is that it is spinning the wrong way. So while the fan was running, couldn't get it recorded, but I just have a little piece of drywall tape here, and I stuck it down in front of the radiator, and then I watched to see if it sucked it up against the radiator or if it pushed it out away from the radiator, and it was pushing it out away from it, so it would appear that it is spinning the wrong direction. So I don't know if the controller did something different, supplied the power on the other side. I don't know, but it could have been pushing this whole time, who knows. But I'm going to go in here and reverse the 2 wires for the fan and see if that gets it to spin the right way. I got my 2 wires for my fan flipped around, so the black one is now going to the relay, and then the blue one is going to my ground wire that's ran up, and it is right there. So I flipped those 2, and I wanted to show you guys as far as like testing an electric fan and seeing if it's pushing or pulling. It's easy enough if you see which way it's spinning and you look at the angle of the blade to kind of figure out whether it's pushing or pulling. But one fail-safe way is just to take a piece of paper. I have this drywall tape here, and you will take it and slide it down in front of the radiator, like that, and I'm gonna jumper it here and show you guys. If I can get this maybe wedged in here or something. There we go. So that's in there, and it's just kind of hanging freely. I'm gonna jumper it, and you can see what it does to the paper once the fan is spinning. Okay. Let me see if I can focus. There we go. See, it sucks it right up against the radiator. So that's what we're after. Before it was just like pushing it out away from it, so it was pushing it out here, even if I tried to hold it up against the radiator. And so after switching the polarity of the two wires of the fan motor itself, we have it working right.